record and put it online today, and then maybe tomorrow I can show you how to get that and what that would look like for if you're absent or you need to go on to do that. But we talked about this briefly on Friday. Interval notation, something that I believe you did in Algebra 2. This book and the calculus book really uses interval notation over set notation. Both are accepted mathematically, but I have seen in the last probably 10 years or so that in college, most college classes expect you to know and use interval notation just as much, if not more, than set notation in math class. So I like it better, but I won't mark you wrong for set notation as well. Except for the very first test, there is a question that says like write in interval notation. But other than that, you can use either. So some vocab maybe that you didn't use in Algebra 2, talking about bounded and unbounded, closed and open. Bounded just means there are endpoints, right? So bounded would be like X is everything between A and B. Including A and B is what makes it closed. And so remember that if it's included, that we show that with a bracket. So I'm just going to draw this over here. So instead of writing the inequality, we could just say everything between A and B. So that's called a bounded closed interval. And I'm going to write, like I have like pretty much every type of interval on here. If you remember most of this and you just want to jot a few things down, like it's up to you on how much you write on this. But maybe the vocab is worthwhile to note because maybe that's something that you haven't used before. So this one is also bounded, but it's open. So the difference between open and closed is open does not include the endpoints, right? And so how do we show that with interval notation? Instead of brackets, we use parentheses. Trying to get better with this marker. Just colors there. And then your book calls these half open. That means one side is closed and one side is open. You can call them half closed, right? Depends on if you're optimistic or not. If you want to say half open or half closed. Either one's okay. If you had to describe it, like I think there's some on the homework that ask you to describe it, and that means they just want you to use these words. So I just gave both options here. If the first endpoint is closed and the second one's open, then that would be bracket A and then parentheses at the end. And it could be switched, right? So this one's also half open or half closed. I don't know if you really need to write all that down, but one side can have a bracket, one side can have parentheses. My yellow is awful. Bounded. Unbounded intervals are intervals that keep going on forever in one or both directions. So that means you're going to have that infinity sign in there. It's unbounded. And again, unbounded intervals could be open or closed, and that has to do with the endpoint that's in there. And so again, just giving you options here of every possible option. If it's x is greater than or equal to a, that would be starting with a and going to infinity. Infinity always has a parenthesis around it because infinity is never included, right? Infinity keeps going on forever. So even though it's closed, infinity always has a parenthesis around it. It'll never have a bracket around it. So I'll put A right there. And then this one would just be parenthesis A to infinity. What about going less than? That just means that the upper limit is the endpoint, right? So if B, everything less than or equal to B, that means that the upper limit is B. And what do I write to show that it's going less than forever? Negative infinity. And just remember that the left side is always the smaller number and the right side is the bigger number. So negative infinity always has to be in the left side. It can never be in the right side because negative infinity is going to left on the x-axis. And then this one would just be negative infinity, not including b. And again, I like set notation because to me, I think it's quicker and faster than the set notation. Some people like set notation because you just write inequalities, and they don't have to think about the brackets, parentheses. And so I'll use both. The back of the book tends to use this notation, and in this one chapter I do kind of want you to do that. And again, I think also it's hard to write all real numbers in set notation very nicely, with but in interval notation to show all real numbers, negative infinity to infinity is just showing that all real numbers are included. We talk a lot about domain and range in this class, and so we'll be writing domain and ranges a lot, and I'll be asking you the limits on functions a lot, and so interval notation is very useful for that. Questions about that? I have a few examples on here, just kind of similar stuff that you're going to see on the homework, and then I have a little extra thing on here just to kind of get you thinking about interval notation and how we can use it with graphs. And then I think the only other thing that I want to talk about is exponent rules, which sometimes people forget, and so hopefully that will be a good thing as well. So the hard part about these is the directions, to write the directions. Describe and graph the interval. The description part, they want you to use those vocabulary words, like bounded, unbounded, open, closed. And graph the interval, I just want to show you how they graph in upper level math. In previous math classes, you've always just used like an open circle or closed circle to show whether the endpoint is included or not. But now they want you to use the parenthesis or the bracket. So just like you do for interval notation, they want you to use that on the number line. I don't care. I don't know how in the past you tried to make number lines. I'm not that picky. If I was going to make a number line to graph this interval, everything less than or equal to 2, you could put a bunch of numbers on it. Sometimes I like to just put 0 on it and then the number, or sometimes I'm really lazy and I'm just going to do this 2, right? I'm okay with that. Up to you and how you want to do it. Put a few more numbers on it if you want. But the big thing I want you to know is this would be a bracket. So instead of putting like a filled in circle like you've done up until this point, this will be a bracket, and it's actually less than, so it actually would be like shaded this way. So I'm going to put a bracket that's supposed to be on 2. I was off a little bit. Like that, and it's less than 2, so I would just shade that in less than 2. So that's a big difference from other graphs that you've made. I think if you know interval notation, it makes graphing it really easy, because if you were going to write this in interval notation, it doesn't say you have to, but if you were going to, that would be negative infinity to 2 bracket. And so if you know the interval notation, you pretty much just translate that right to your graph, the bracket or the parenthesis in the same spot. Describe this. Is this bounded or unbounded? It has infinity, so it's unbounded. It goes on forever. And is it open or closed? Closed, because when it's unbounded, that one side of infinity is always going to have a parenthesis, but what's the bracket or parenthesis on the other side is what is going to determine that. So since it's a bracket, we would say unbounded and closed. The interval notation part, they didn't say you had to do that. I just added that in, but they did want a graph and they wanted you to describe it. What about number 2 here? Again, I'm not really picky. Like, that's how I would make my number line, and I'm okay with you making your number lines like that. If you want to add more numbers, you can. When it's in interval notation, just like I said over here, I think it's really easy to graph it, right? Like, we're just going to bring that straight down, and we're going to put the bracket here and the bracket here. It's everything in between -3 and 3. And what would the description on this one be? Bounded and closed.
you want to write the directions there. Maybe you can just write the bill is at least 29 years old.
A lot of things in math class you might not think applies outside of math class, but I feel like inequalities, maybe you don't write them as inequalities, but people use the language of inequalities outside of math class all the time. And so on your homework today, there are a few questions that just ask you to take the description and write it. Let's see, they say write both integral notation and inequalities to describe the set of numbers. And words like at least, at most, those words always seem inequalities, and so you always want to think about which inequality sign applies to that, especially as you get into story problems. You want to make sure that you're using the right symbols there. Bill is at least 29 years old. Does that mean greater than or less than, greater than or equal to, less than or equal to? I got a thought. You know what I'm going to do? So in my summer class, she gave us all numbers, and then she rolled dice, and then whatever number you rolled, that person had to talk. Whether you already talk, or I'm going to just make you off numbers. Would that be exciting? Six? Well, I've never done that before. I think someone else. I have done that. Or I can put all your names to hat, and then I can learn your names better, because then I have to do all your names off and make you talk. I'm not prepared for it today. What do you think? 29 means less than or greater than? Sorry, not 29. At least means less than or greater than. I'm going to use B for Bill. You can use X, you can use N, you can use whatever you want. That's what's graded out for. At least greater than or equal to 29. Interval notation. Pretty tell me what right for interval notation. And parenthesis or bracket on the 29. Always parenthesis, right? Right, that's not so bad. Especially on the homework, it's not so bad because you don't have to write directions. Okay, I don't want you to write this down necessarily, but what I want you to do is I want you to take a couple minutes to think about this and then talk about it with someone either next to you. You kind of pair up, person behind you, person next to you. If you need to go like 3 people, that's okay. But I want you to think about some answers to this and be ready to talk about it. And I actually have 4 of these. Let's see if I can dual page this. Let's see if you can still read it. Can you read that still? And so this little E there, that's just a fancy math term for like an element of, so it's just saying like the range is this, so don't get thrown off by that. But it says graph 2 different parabolas that have a range, so maybe you have to think about what range is again. How many different parabolas do you think are possible? What is the greatest number in this interval? That one probably is maybe easier than number 1. Explain how you know the answer. What is the biggest number in this interval? How do you know the answer? And then maybe you used this notation last year, maybe not, and if not, we'll talk about it. But what if I wrote something like this, which just means this union this? Is there a better way to write that interval? And so you can jot that down in your notes, but I want you to go ahead and just pair up with someone if you want to think about it by yourself for a minute, but have some discussion because I want you to give me some answers to this when we're done. And maybe I will write your names on paper right now so that I can call on you. So let's take like 7 minutes. Go. We can move it. and then we can get other people's opinions. So don't feel like if you don't have any clue, like it says, please tell me what you do know about it, and then we can go from there. Okay, so maybe we'll skip number 1 at first, but people seem like stressed about that. It's a lot of vocab in that one of knowing what all that means. Okay, ready? We'll skip number 1 for now. We'll come back to number 1. People are stressing about that one. Number 2, I want whoever's in my call, I want you to tell me the answer, and I want you to tell me like why that's true. All right, that's what I mean by explain. Like, how do you know, or how did you get that answer? I learned names too. Sabrina Phillips. What is the greatest number in the interval from -6 to 8? What do you think? 8. How do you know? Right, right. Anyone else have any other thoughts on that? Anybody think of it as disagree with that? Like the bracket? If you graph that, 8 would be the highest number that you included where you shaded, right? I agree with that. So, what about number 3 then? Allison.
Well, I know that it is an open interval.
It is open, yes. So if we graph that, let's go that route. What would it look like? If I have 13, 28. So is the answer on like on number 2? Do you think the answer is 28? Does anybody have thoughts about what they think the answer is?
Like get 28, but you get as close as you want.
Oh, 27.9 repeating, you mean? Anyone else have thoughts on that? So, let's talk about the line above it, right? The repeating bar line. Definitely it's a thing. 27.9 repeating, like the repeating bar line means that it repeats forever. Have you all taken chemistry with Miss Dow? Does she like yell at you about using the repeating bar line? Science people don't really like when you use the repeating bar line. Like they want you to just use like significant digits and do that. So I agree that that is a really close number. My answer is that there is not a greatest number because we could keep getting closer and closer to 28 and not really touch it. And the idea with the open interval is that we don't ever actually get to it. That's why we call it open instead of closed. That's kind of some crazy calculus talk there, but I don't know. I kind of I see that argument too, though. So, what are your thoughts? Think that's too crazy to say there is no biggest number? Kind of goes back to that whole idea about infinity that we talked about on Friday. How many numbers are between 13 and 28? Could you count all the numbers between 13 and 28? Could you count all the integers between 13 and 28? Definitely. 13, 14, 15, 15. Could you count all the real numbers between 13 and 28? There's infinitely many there. So just kind of keep that in the back of your mind right now. We'll say 3 we're kind of
in between right now? Do we think 27.9 repeating is the answer? Or could we think about that we never could actually get to 28? That's some crazy math talk, but there you go. Does it feel weird to say that there's a math problem that we don't agree on the answer? It's kind of weird to think that, but it happens sometimes. I heard lots of talk about this, union. What did we come up with? Oh, what did we come up with?
Maybe step one, explain someone if you can know what that means. Other than if not, you can just talk about the answer. Miranda. Miranda? Where's Miranda? Oh, I was like, she moved. She moved.
Number 4.
Well, I think it would mean this negative because the 9 and 2 are very
Yeah, and so this just means like, remember when you do like and or stuff, like this and that, or this or that? The union just means and, so it's like both together. So I like her answer. If I graphed from negative infinity to 9, that would be up to 9 and shaded this way. And on the same graph, if I graphed 2 to infinity, that would be not including 2, but to infinity would include this. So the union was kind of important to know it means this and this together. If you graph both of those on the same line, do you agree that the whole number line is shaded in? So yeah, sometimes when we're doing domains, we look at each individual part, and so something that we want to look at is there a simpler way to combine them? And you're right, the answer to this is it's much simpler to say that's just negative infinity and infinity. All right, let's go back to 1 for a minute, and let's just talk together. I won't call a name out right now. About, first of all, what is a parabola? Like this, right? Like x squared is the parabola that starts at 0, 0 and just opens up. Quadratic, that's another way for it. What does it mean when it talks about the range of a parabola? What does range mean? Everybody have any thoughts on that? What if I graph y equals x squared? That would be at 0, 0. If I plugged in 1, I would get 1. If I plugged in 2, I would get 4. If I plug in the negatives, I get the same thing, right? It's symmetric. Oh. And I would get this lovely parabola that hopefully you're somewhat familiar with. What is the range of that graph? What does range mean? What am I talking about if I ask you for the range? The y's, right? Where is y included on this graph? On a like on a linear line, like if I drew a line like this, the range is all real numbers because one arrow goes up forever and one arrow goes down forever, so every y is included, so the range is all real numbers. But on a parabola, the range is not all real numbers because the arrows go in the same direction. So you want to ask yourself, like, what is the lowest or the highest y value, and is it going up forever or is it going down forever? So going back now, what is the range of this? Definitely has starts at 0, right? So the range of that would be 0 to infinity, or is it negative infinity up to 0? Which the positive y's are included, right? So it would be including 0 to infinity. That would be the range of the graph y equals x squared. Does that help? Okay, so now let's think about this problem again. Could you graph 2 different parabolas that have a range from 2 to infinity instead of 0 to infinity? Or maybe if you don't know the answer yet, could you graph 1? Could you tell me where I could make one parabola that has a range of 2 to infinity? Patty, wait.
Can I graph it?
Yeah. Yeah? You want to graph it? You want me to erase this one? Or just leave it there? It's very touchy. Be prepared. Yeah. Perfect. So instead of starting at 0, 0, she just moved that vertex up 2. Can anyone think of another way? Just move it over like this. Is that hot? Anybody think of another way? Make it slimmer, like, oh, that's really skinny. Like a really skinny. So, moving on to this question, how many different parabolas are possible? What do you think the answer to that is? Yeah, I think there's going to be infinitely many. Because could we slide it all the way across this line wherever we wanted? We can make it thinner. We can stretch it out and make it fatter as long as that vertex starts there. And what about, I instantly thought of this, what if I just made it open down at 2? That gives you a whole nother variety of graphs. So, infinitely many, because you could just keep translating it or transforming it along that line. All right, and again, that's just kind of a notation. That's why interval notation is important, because when you have problems like that, if you don't know what the intervals notation means, it makes it a lot harder to answer those. All right, this is maybe me jumping ahead a little bit for this, but I think it was a good little activity to get you working. Okay? Any other thoughts about this before we move on? Oh, look, that's not right, right? What did I just do? That's not right. I'm a failure. That's negative infinity to 0. Right? Thanks. You have to tell me when I'm wrong. Don't tell me. I was wrong. Okay. That's automatically what I wanted to do, though. Oh, that's not right. Single page. Okay. Exponents. My last thing. A couple examples of this, and then I'll be done. These are in your book. I wrote page 8 here. If you don't want to write these all down. Here's why it's a good reason to take notes in here. When we have a homework quiz, you're allowed to use your notes. You're not allowed to use your book. But if you don't want to take notes, it's your prerogative. I think you learn exponent rules, I don't even know. I think they start somewhere in middle school, that you learn them for the first time, and then you learn them again in Algebra 1, and then you learn them again in Algebra 2, and now we're going to go over them again. And it's just things, people get these mixed up very easily, so I'm going to go through them, but it's something that you can always think through. To me, it's, if you forget whether you should add the exponents or multiply them, if you just kind of write it out, it should come to you. So there's a whole lot of letters up here, U's and V's and M's and N's. I'm going to write a few like real examples next to it just so you can see it. But if you have the same base and you're multiplying them, you just add those exponents, right? So that becomes U to the M plus N. And that's just like if you had x squared and x to the third. Why do you add them? If you ever forget on a test, oh, why did it change to black? You can just say that's 2 x's and that's 3 x's, so that's 5 x's. So that's why the shortcut is you just add them. If you are dividing the same base with exponents, you just subtract them. So that's u to the m minus n. With dividing, I tend to think about crossing out more than I think about subtracting. But again, if you had x to the third over x squared, right? X over x is just 1. So it works out that if you just subtract 3 minus 2, you have that 1 left over. And so I always say, like, just think through it. If you forget, do I add, do I multiply, do I subtract? Just kind of write it out or write a smaller example out, and it should help you. Anything to the 0 power, people always want to say 0. It's really 1 because my explanation to that, we can look at some patterns, but basically it's like there's that 1 in front of it. There's not any u's left, but it still has that coefficient in front of it. Negative exponents. A negative exponent is just a way to write the reciprocal. When I teach Algebra 1 and ECA lab, I always teach that your negative is your ticket to cross the fraction bar. So if you have a negative exponent, you have to go across the fraction bar and turn in your ticket to get across there. And so that just becomes 1 over u to the n. That means if you're negative in the denominator of the fraction, you have to turn in your ticket and move to the top. The top and the bottom one here are very similar. If you have multiplication or division, all with the exponent to the outside, you just give that exponent to everything on the inside. That doesn't work with addition and subtraction, right? You have to FOIL that out, or multiply that out. But on these, you just give that m to everything. So that's just u to the m, v to the m. It's like distributing, but not really. And this one is just u to the m over v to the m. And then this one I think should have been grouped over there, but that's okay. If you have a power to a power, you multiply. So that's m times n. It looks like minus, but that should be multiplication then. And again, my explanation of that one. If you have x squared to the third, that means you have 3 sets of x squared. And then you just count 2, 4, 6. But the shortcut is that you multiply. All right, I go through this. I just went through this in calculus today because people forget these rules, and it just comes up the algebra of it. So you just need to know it. So let's look at a couple examples. Some are easier. Some are get a little crazy with the negatives. And there's multiple ways to approach these. So I'll try to do a couple ways, but as long as you get the right answer, I don't care which way you do it. Everybody okay with that? Is that fun? Stop me if I go too fast. Skip these and go to the crazy ones. Really, interval notation and exponents, those are the two things on your homework today. The exponent stuff always is like stuff that we go over the next day. But on number 4, that's just all multiplication. And remember that the associative property allows you to kind of mix things up when you're multiplying. So I just group the numbers together, the A's together, and the B's together. I don't really think about it, but you can do that with addition and multiplication. You can just kind of group it together. So 2 times 5 is just 10. And then remember that there's a 1 there. So a and a squared. I'm just going to add those together because I'm multiplying. So that's a to the third, and b to the third, and b to the fifth. 3 plus 5. And 8. That's it, right? Only math for all we do that. Number 5, you have options here, all right? Some people just automatically look at those and you're going to subtract your u exponents, subtract your v exponents, and deal with it from there. Some people make lots of negative mistakes and they're going to get rid of their negatives first, because if you see a negative sign, you're allowed to move that across the fraction bar. That's okay too. The big thing is your final answer should have no negative exponents in it. So I'm going to do this 2 ways, and then we can kind of talk about maybe if you like one way better than the other. So when I teach algebra 1, which this is not algebra 1, but when I teach algebra 1, they tend to mess up subtracting negatives a lot. So I always teach them, step 1, get rid of all your negatives. So if you have a negative, you add your ticket to cross the fraction bar. You don't have a negative, you don't. So I would teach u squared doesn't have a ticket. It has to stay there. But v squared has a ticket to move to the bottom. U to the negative 1 has a ticket, so it gets to move up and drop its negative. V to the third has no ticket. So you don't have to worry about messing up negatives if you do that. And now it worked out really well that my u's are on top together, so that makes u to the third, and my v's are on bottom together, and I'm going to just add those as v to the fifth. The other option, you've been doing this a while, you have a calculator, you don't mess up negatives, you can just subtract, right? 2 minus negative 1, right? I don't know if I want to show that or not. You have u to the 2 minus negative 1. Oh, that's really messy. And this one would be v to the negative 2 minus 3. Minus the negative becomes u to the third. Negative 2 minus 3 is v to the negative 5. then you gotta move that negative down, which means you would still end up with u to the third on top, b to the fifth on the bottom, right? So they're kind of different ways of going there. And the more complicated you get with like another, like if this was all in parentheses to another exponent, you just have to kind of work your way through it. And so let's maybe do one more of those. Questions about that? Don't leave negative exponents in your answer. That's not simplified. Oh, wow. Just like order of operations here, if you have an exponent on the outside of parentheses, you got to deal with that. I would deal with it first before I start moving stuff, because otherwise you might get a little confused moving your negatives. And remember, when the exponent's on the outside, you're multiplying those exponents together. So watch your signs, don't make silly mistakes. So I would multiply that exponent inverse. So that's going to become x to the positive 12, y to the negative 8, y to the negative 12, x to the 8. Any questions on where I'm getting that? What do you think? Do you like them moving the negatives, or do you just want to subtract? Make sure you only keep x's with x's and y's with y's. And it's just subtracting from here. So if you were doing your x's, you would do 12 minus 8, which would just be x to the 4th, right? Watch your negatives here. What am I going to get on y here? Y to the negative 8 minus negative 12. Negative 8 minus negative 12, I believe is going to become plus. So that's just going to be y to the 4th also. You can't even read that. I'm struggling. It's very touchy, so even if I have to like pull the pin back where it connects everything. And I'm okay with that. This is pre-calculus. You don't have to show me a million steps. If you like showing lots of steps, that's okay too. Like do whatever helps you as you're doing it. I think at least that one step is needed in between. Questions? I think that's it. So this is homework P1 because this is chapter P, page 11 through 13, and I kind of just jumped around. So there's 15 problems there, but lots of them are just interval stuff, inequality stuff, and then the exponent stuff at the end. So not a lot of work, and it is only 15 problems. Tomorrow I'll try to have a assignment sheet for you, and we will just start when you come in. I don't do bell work in here, but what I want you to do when you come in is while I'm doing attendance, you could go ahead and start asking, like if you had a question on homework, maybe you can get that answer, or you can find out that someone else had the same question on it before we start. And so that's kind of our start to the day, is you go ahead and start talking about homework with each other. Doesn't mean copying homework, but checking with each other on questions that you had, or if you got it all done, maybe you can help someone that didn't. And then after I get attendance, we'll spend 5 or 10 minutes each day going over questions that you had before we move on. Okay?